Good morning, everyone. My name is Huda Kayaki, and we're here today to present the new features in the latest release of Thermolib, the 5.3 release. I'm just gonna jump right next to the new features. So we basically added improvements to three major areas in Thermolib this time around. First is the components, the chemical media data, and the visualization parts of Thermolib. I'm going to show you most of these in MATLAB directly. This is only an overview of all the features we added. So first, let's start with the components. We improved on the source blocks in Thermolib in that you can add external inputs. For that, I'm going to jump directly to MATLAB. So I prepared here a small demo model. So this is probably what you already know from Thermolib. You have two source blocks, one of a pure substance source and one of a mixture source. And the parameter for these sources are given, or at least until now, they were given inside the parameter block. If you wanted to, say, vary the temperature during the simulation, you had to build around this block and break the library link. We changed that with this release and using these checkboxes that you see here next to the parameters. By clicking these checkboxes, for example, let's use the temperature. You tell the block that I would like to use this property as from an import port and not as a parameter. So, for example, here I click the checkbox for temperature. I click OK. And temperature can now be read from the input port, which I will connect here to a constant block. I'll do the same thing for the mixture source. So you can see it's here for the flow rate, for the temperature, for the pressure. I'll use the temperature. The cool thing about this is you can also specify the temperature in which unit is the temperature should to be read. So before we had to use always Kelvin when you needed to change the temperature from the input to the source block. Let's use now Celsius. I'll connect this to this and run the model. So during the simulation, if I change the input temperature, you can see here in the flow displays it's at 250. I'll change it to 25. It changes accordingly and the thermodynamic state is corrected accordingly too. This is very useful when you have data that is coming from measured data that you would like to include in your simulation. Then you can just read these data directly from files or the workspace, use a from workspace block or from file block and connect it directly to the input. So that was for components. We're moving on to chemical media data. There are two new features, actually one new feature, and we're introducing a new tool that will be shortly available on our web shop. So I'll start with a new feature, which is the ability to define new atoms. I'll show you this again directly in MATLAB. We'll open first of all the chemical media data where all the species and atom data is stored. This is under the Thermolib installation, under data, and then chemical media data. Open it outside MATLAB. So we have a new data sheet in this file called elements. Before we only used to have the chemical media data sheet and the constants. And now we have the elements where you can define new elements that you can use in your in your species. So as an example, I'm going to add today iodine. You just give in the new element here in the table, give it a name. This field tells Thermolib whether this element can be burned in the lambda burner. In case of iodine, we're going to go for no, so we don't need the combustion products for this element. Yeah. So I have iodine. Now I can go to my chemical media data, and if I would like to add a new species that contains iodine, then I can do that. But before that, I will have to add a row for iodine. So I'm going to go ahead I'm going to do that by copying the argon row, doing a insert, and then just changing the title here. It's important to change this here with the I atoms because Thermolib is going to look for this variable in the workspace. Let's just make a dummy element, call it webinar for today. and I'm gonna copy its values from, let's say, water. Laminar, and let's say this element has 1 atom of iodine in it. I'll save the whole thing, and then to import this into Thermolib, we just go back to MATLAB and open the Thermolib get chemical media data. Thermolib get chemical media data. This opens a new dialog where you can select this Excel file that we just changed, and you select the mat file where this will be saved to. I'm just going to select the default Thermolib file, which is chemical media data that you can find under the data directory. Thermolib. Yeah, I'd like to replace it, and you just click OK. So now when I open a Thermolib model, so this is a regular power plant model, and I go to the model setup. Here under select species, if you try to add a new species and you look under the drop-down menu, you will see our new species that we just added, the new compound, webinar. I'm gonna add it to my model. It's now here listed. Click OK. And I'm gonna add it just like as a dummy compound in this cycle. So to do that, I'm going to go here to this initial conditions block and just say that the cycle contains not only water, but my dummy compound. And run that. So now when this dummy compound and the atom iodine is now included in all the balance information about this model, I'm going to take actually this opportunity to demonstrate to you again how to do a balancing of your model. So when we ran it, it created in the workspace a structure called S-model balance. And this structure contains energy and mass balance information about the model. To see this in a more readable form, you have the ability to export this to an Excel file, which you do by using the command export balance GUI. I'm going to open that. It will export this structure as model balance to an Excel file. Just going to call it balance. Okay, the exporting is done. Then we go to the directory. Here's the file I just created. So this has two sheets, one for balancing the energy in the model and one for balancing the mass. We're interested now in the mass balance because to see our new compound and more importantly our new atom that we added. So as you can see here on the mass balance, you can see our webinar compound. Obviously nothing happened with it, it just went and it just cycled through the cycle, but you can also see the balance for the new atom we added. We had this we had a lot of requests from clients that they wanted to add special compounds that had atoms that were not on our original list. And this is our answer to them, that they can now add the atoms, whatever they need, add whatever compounds they need, hopefully without too much overhead. Which actually this brings us to the next feature in our presentation today, which is how to import new media data in Thermolib. So we had also a lot of questions from clients. They have this compound, but they were not sure how to go about getting all the chemical properties and thermodynamic properties for this compound. And for that, we developed a new tool. This tool is not in the current release, but it's going to be soon featured on the web shop. So I'll go back to MATLAB. So I'm going to start the tool by calling species data import. So first of all, in this tool, you have to specify which source of media data are you going to be using. If you have Refprop installed, then you can use Refprop. Otherwise, you can use NIST or data from a formatted text file. For this demonstration, I'm going to use Refprop, and I'm going to go here. It shows me all the media that are available in Refprop, and I'm going to just pick one out. Let's take ammonia. So first of all, I have to fit the data from Refprop to our Thermolib internal data. So here you specify the temperature range during in which you're going to use ammonia, and how detailed would you like the Thermolib tables to be by specifying the number of steps in between. I'll just use the default information and just click Fit Data. Now it's getting the data from Refprop and fitting it to Thermolib. So to see how good our fit was, we have here the ability to plot and compare this data to the original data in Refprop. So the information that we imported into Thermolib and compare it to the source in Refprop. So we'll take the fit bounds from the fit we just defined, and I'll click compare to source, and then I will click plot. You probably cannot see this very clearly, so I will zoom in. So now it's actually showing both the Thermolib data and the Refprop data. If I zoom in, you will see there is a slight but minimal variation between the two plots, but this is really minimal and does not affect the quality of simulation in Thermolib. So now that I see that my data is okay, I controlled it, I can now save this into a chemical media data file by clicking here Save XLS. And I will just name it Chemical Media Data 2. Save. So I'll open this outside of MATLAB. So now you can see the file. It added it to the file where we already added the webinar compound. And then it has already added all the information. When you import this file again using like I just showed you for the webinar compound, into the Thermolib workspace, then you have your compound available there. The last area that we added improvements to is visualization. So first, now you have the ability to see live during a simulation how your thermodynamic state is varying on a pH diagram. I will show you this directly. And also we improved the readability on pH and TS diagrams, so by adding labels and multiple isoline sets. I will also demonstrate this shortly. So going back to MATLAB again. Okay, I'm going to go back to the main folder. I already prepared a model. Let's open a Carnot cycle. So this is a regular Carnot power cycle. We added here some pressure changes at these points to introduce some change in the model so we can see changes in the state so it's not steady. We have here 4 states, and we would like to see how our states vary during the simulation. To do that, there is a new block in the Thermolib library. If you open Thermolib and then go to Things and select State Plot, this is the new block. I'll drop it directly into my model. So this will allow me to see live, like during the simulation, how my states are varying. I'll first open the parameter block, and first of all, I have to define the number of input states that I have. Since we have here 4 different states, I have 4 inputs. Then you define what kind of plot type you need. So you have a pressure enthalpy plot or a temperature enthalpy plot and so on. For now, I'm just going to stay with a pressure enthalpy plot. You define also which species would you like in this particular diagram. You don't have to use all the species that you have in your model. Just specify the ones you want to use and their concentrations, the unit of the concentration, and then you also specify the range of the temperature and pressure to be plotted in your diagram. So here we have a linearly distributed range of temperatures between 330 and 460 Kelvin, and a logarithmically distributed range of pressures between 3 and 7 bar. There's a few other parameters. You can define the style of the marker that you want to use, so we're just going to use a plus. Yeah, that's it. You have also the option of saving the data on your plot. I'm going to leave that out for now. Just click OK. That was it. And now I have to just connect my states. And hit run. So it opens the plot for me automatically. And you can see here states 2 and 3, how they are varying during the simulation on the plot. Yeah, so this is the live plotting of states feature. I'll go back now to the model and just stop it. Finally, the last feature I would like to present today is adding the labels on diagrams. The best way to show this is by showing you how it looked like in the previous version. So I have here the previous version of Thermolib open. I'm just going to make a plot, a pH plot of, forgot to add an element, of, let's take again ammonia for today. So here you have the pH plot, you have the isothermal lines. It's the problem with it is it's a bit difficult to see which temperature does each line correspond to without any labels. And this is what we improved upon in the new version. If I do the same command in the new version, keep forgetting the compound, H3. So at first sight it looks a bit more busy than the older version, but it's because it has a lot more information in it. So first of all, I'm going to zoom to a smaller range. So first let's look at the blue lines, the isothermal lines. I don't know if you can see them properly on your screen. You can see that there are now labels on the temperature lines. And also here we have the isotropic lines, the green ones. There are also labels that specify each line, the entropy at each line. The black lines that you see here, these are the isochoric lines. The labels are a little bit far out here at the end. Finally, for today, I wanted also to give an overview of our new Thermolib shop. This has been online for a couple of weeks now. We have added to our website a complete web shop where you can buy the Thermolib license online without any overhead. You go by choosing, your area of application, whether it's going to be academic, commercial, for student, or for training. And then under each section, you can decide which kind of licensing you would like to use, and then you can directly download your Thermolib product. We also have a free trial for 30 days that you can immediately download without any overhead like we had before. So this is it for our features today, and if you have any questions, we're here to answer them. Okay, we have a question. So Yuri, you're online. You can ask your question.
What difference between the new visualization tool and XY graph in Sync's sub-library of Simulink library? In my point of view, they have the same ability to plot XY graph.
Hello. Maybe I try to answer this question. So my name is Alexander Lavenka, and I'm also attending the meeting here from EUtech side. So yeah, the big difference is that you have the possibility to have already some pre-configured lines in the background of the diagram.
Okay.
If you use the standard XY plot from the standard Simulink block, then you just can draw one line, and the advantage is that you can have multiple inputs on one hand. So you can directly feed the Thermolib state buses into this block, so you don't have to decouple the elements of the block by yourself. So otherwise you would have to select the temperature separately, the enthalpy separately. Of course you can do it by yourself. The advantage is that you have this background image of the isothermal lines in this case, what we see right now, so that you can select certain temperatures where maybe this is your desired operating range and you want to stay inside of these bounds, for example, and you have the possibilities to use, like here, the logarithm of the pressure instead of just the pressure by itself. So the standard diagram which you would use for the thermodynamic analysis. And yeah, that's the main advantage. And you work really with the cycle as it is in the as you would work on a sketch on a whiteboard or something like that. That you draw the edge points of your circle, of your cycle, of your thermodynamic cycle. So that means that is also something you cannot do with the X-Y plot in Simulink. At least as far as I know. There's no possibility like this to draw closed shapes. You would have to program that by yourself. That's the difference.
Okay, I see for now we don't have any more questions. Then I'm just going to say thank you for attending our webinar. And if you have any information, you can contact us at any time on our website. We'll be here to help you. Thank you.